which is just to walk us through your road from net energy gain to commercialization and how you scale this and get it on the grid. Because obviously, you referenced the sort of technological history, right? But the power grid is a crazy animal that is sort of, it's very messy to get things onto the grid and to get new technologies into the space that I'm sure you're in.
Yeah, so maybe I'll actually go back and I'll try to give my view and a view that we've developed with some of our partners of basically what to watch for on the path. And I'll go to the very basics, right? You think about the steps that you need to see for anyone that wants to build a fusion industry, fusion power. These are really about fusion power integrators, people that are building power plants. The first step is you gotta actually write down what you think your thing is, right? At a level that can even make plasma. Step one, make a plasma and something that you can describe. Right? Luckily, most of everyone in the room has done that. Step two, make that plasma hot. That's actually really hard. There's only a few things that got hot enough. You need really complicated diagnostics from people like the DOE to come help to make sure that you're actually getting hot. Hot is 100 million degrees. Maybe 10 million degrees is good enough to really be in the fusion machine. Step three is actually make it to the point where the triple product is fusion neighborhood, even in the fusion neighborhood. There's really only a couple concepts that have reached that point. Step four, make it so that you're actually making real, honest to goodness fusion heat. Push a button and the heat came from the fusion reaction, not from putting things in and out of machines and no smoke and mirrors. The fusion fuel was combined, fusion reactions happened, and heat came out. That's what NIF did. So it's super exciting. So that's the vanguard right now is that. We're building a machine in California, or not California, in NIF to California, we're in Boston. That machine is designed to do that. More power, out and in, real fuels, push a button, everyone can come and see it, measure it, show the world. The next step is now do that in a machine that actually takes the heat and turns it to electricity. There's lots of different ways you can do that, but that's an important step. When you look at a meter, and the meter is spinning because stuff is leaving the site. You're not just cycling it around, you're not just borrowing it, you're literally making electricity that didn't exist before in a way that someone will pay for you because it's verified. It's coming off of your meter. That's what we're planning to do in the early 30s when people ask that. And then the last step, six steps to fusion, half as many as traditional 12-step. That is make it economical so you can scale it. If it's economical, you will scale it. So we're at step 4, building Spark. Our plan to step 5 is to take that concept of Spark that's about halfway through construction and make it about twice as big and sort of scale it, as a picture. Or my engineers would be upset with that analogy. And then that is a power plant. And that would be about a 400 megawatt power plant. There's a lot of things that have to go right to do that, but we don't think there's a lot of discovery that has to happen between the step we're doing right now and that net electricity from fusion fuels out on the grid.